Okay, this is Math 31, section 3.1a. We're going to get into symbolic logic, where we're kind of using language and statements and looking at how language is defined logically. So what we're using is called Aristotelian logic, which is coming from Aristotle, okay, who's called the father of logic. Okay, so the ancient Greeks were the first people to look at the way we think and draw conclusions, and using language in that context. So this has been studied for more than 2,000 years. Okay, this was something that was happening, in BC. Okay, and Gottfried Wilhelm Leibniz, who was around in the 17th century, was the first to seriously study symbolic logic. Okay. So he believed that all mathematical and scientific concepts could be derived from logic. So believed all mathematical and scientific concepts could be derived from logic. Okay. So in this type of logic, we use symbols, generally letters, to represent written statements. Okay. You don't need to know these names or the history for tests or anything. We're not going to quiz you on that. Okay, on to the 19th century, George Boole was considered to be the founder of symbolic logic. Charles Dodgson also incorporated many interesting ideas from logic into his books. That was a little bit later on. He's also known as Lewis Carroll, who you may recognize as the author of Alice Through the Looking Glass or Alice in Wonderland. Okay, so this is how symbolic logic is structured. First of all, we have connectives, and those are words like and, or, if, then. Okay, so they connect statements, okay, or ideas. An exclusive or, which means one or the other, but not both. Okay, now that's kind of a new thing for us. What we looked at or union before. Inclusive or, that was this: one or the other or both. Okay, so we've looked at inclusive ors before. Now we're going to look at exclusive ors, which means it can't be both, but as long as it has to be in one or the other, but not both. Okay, for exclusive ors. So we'll look at both of those. Okay, a statement is just a sentence that can be judged either true or false. So we'll know whether a statement is true or false. And when we label that, we're assigning a truth value to that statement. So that's labeling a statement as true or false. Okay. So when we give a truth value, you say, hey, this statement is false. The sky is brown. That's false. Okay, we talk about simple statements. That's a sentence that conveys only one idea and can be assigned a truth value. Okay. So that might be something like the sky is blue. Compound statements are sentences that combine two or more simple statements, and they can also be assigned a truth value. So we could say, the sky is blue and it is sunny out. Okay, that would be a compound statement, and it's connected with an and. Negation of a statement means it's change a statement to its opposite meaning. Okay, so negation of a false statement is always true, and negation of a true statement is always false. So we always go from false to true or from true to false. So let's say my statement is the sky is blue. The negation would be the sky is not blue. Okay, quantifiers. These are words such as all or none or no, some, etc. Okay, we have to be careful with these when we negate these statements, because they're not always what you think they are. We'll look at some examples where we negate some of these statements, what happens. So, for example, if we say all are, our negation cannot be all are not. Okay, because when we say all are, that means every one of them is. So the negation of that, now that would make this not, like say this is true, what would make this not true is to say that some are not. Okay, so we have to be careful with the negation of things like this. Okay, when we have a statement that says none are, the negation would just be that some are. Okay, see, it's just what makes that statement goes from true to false. Okay, for a statement some are, the negation would be none are. Okay, and for the statement some are not, the negation would be all are. So think about like what makes, if this statement is true, what makes it false. So if we say, all cats are brown, we can say, well, no, because some cats are not brown. Okay, we don't have to say all cats are green. We just have to say some are not brown. Okay. If we say no cats are brown, to negate that, we could just say, well, no, there are some brown cats. So that's not true. Okay, so that would negate it. If we say some cats are brown, and we want to negate that, we say, no, there are no brown cats. That would negate that. Okay. And then finally we say, well, there are some cats that are not brown. Well, we could refute that by saying, no, all cats are brown. Okay. Now, we didn't talk about the truth value of that statement, right? But we're just saying we're just negating from here to here. So if this is always true, this is always false. Okay. So we're negating the other statement. So notice that we go from all to some, from none to some, from some to none, or from some to all. Okay. So we kind of have this negation of quantified statements. All are goes to some are not. That's a negation. And some are goes to none are. Okay, so we can kind of think about how they cross over like that. Okay, we would not go from all are to some are. That doesn't negate it. We'd not go from none are to some are not. Okay, those do not negate each other. So we have to be careful that we all are negates by saying, well, some are not. Okay, some are, we could say none are. Okay, as a negation. Okay, so let's start with the statement. Some books are novels. Okay. Now, that means at least one book is a novel. Okay. Some, it could be one, it could be hundreds, could be thousands, but at least one book is a novel. Okay. That's what some means. So some means at least one. Let me write that down. Some is the same thing as at least one. Okay. So the negation would be, well, we could say some books are novels, or we could say at least one book is a novel. That would mean the same thing. Now that is true, right? The negation has to be false, so the negation would be no books are novels. Okay, so this would be a false statement because there are, some books that are novels. At least one is, right? Okay, let's look at another one. Write the negation of this statement. All coins have the image of George Washington. The negation would not be no coins have the image of George Washington. All we'd have to say is that some coins do not have the image of George Washington. In other words, hey, there's at least one coin out there that does not have the image of George Washington, so that would negate this. See, think of like a counterexample like we talked about when we did our induction or deduction, that all we have to look is one counterexample to show that something's not always true. So here they're saying that all coins have that image of George Washington. All we have to do is say, no, there's at least one that does not. So we can say some coins do not have the image of George Washington as a negation of this statement. All. Okay, so as we said earlier, statements consisting of two or more simple statements, these are called compound statements. And the connectives that we join these two are and, or, if, then, if and only if. Okay, so we'll look at those different types of connectives. Okay, the symbol we use for negation is this little squiggly, like little squiggly dash, and that's red not. Okay, so we're going to put it in front of the statement. So if we have a statement P, the negation of that would be squiggly P. Okay, we can put a little squiggle in front of it. Okay, so this would be the negation. That squiggly P, the negation of P. Okay, in other words, if this is false, this is true. If this is true, this is false. Always. Okay, our and statement is called a conjunction. Okay, and we use this kind of like an upside down V symbol. Okay, that's a symbol for conjunction, and we read that as and. Now that's very similar to where we took the intersection of sets, so we'll kind of look at parallels with that. So we can say the conjunction of P and Q is P and Q. Okay, so when we see that upside down V, we say and. Okay, now some of the words that we also use besides and would be but. So but is used just like and, however, and nevertheless. So those are all equal to the same thing as and. When you see these words, but, however, nevertheless. Okay. And kind of think sort of like intersection. Okay. Okay, so let's write a conjunction as an example. So let's say we want this statement to be written using symbolic form, using our letters. So let's say Kanye West is not on tour, but Kanye West is recording a new CD. Okay, so we're going to use letters to represent the simple statements. So let the letter T represent Kanye West is on tour. Let the letter R represent Kanye West is recording a new CD. Now, when you use these letters to represent simple statements, make them positive, make them affirmative. So we're not going to use not for T, okay? When we're going to say Kanye West is not on tour, then we're going to take the negation of that. So always make your simple statements affirmative. So they're not going to have a not in them. Okay. So T will be Kanye West is on tour. R will be Kanye West is recording a new CD. So in symbolic form, the compound statement would be, since we're saying Kanye West is not on tour, we're going to take the negation of T. Okay, so there's that squiggly T. And compound statement, connector, conjunction, sorry. R is Kanye West is recording a new CD. So using symbolic logic, we write it like this. This means Kanye West is not on tour and Kanye West is recording a new CD. Okay, the disjunction or statement is just the V there. Okay, so we call that disjunction and we read that as or. Okay, so in this case, we talk about or, we're using the inclusive or, which we've already been using. Okay, so when we talk about or, we're going to be using inclusive or in this type of thing, and that's kind of what we've been using with our sets too. Remember, we included the ones where it was in both. So the disjunction of P and Q is P V Q, or we can say P or Q. Okay, so we would read that as literally as P or Q, whatever those statements are. Okay, so let's look at an example of that. Let these statements be defined. P as Camilla will take chemistry. Q will be Camilla will take French. Now notice both of those are affirmative statements. There's no not in them. Okay, and we want to write the statement in symbolic form. Camilla will take chemistry or Camilla will take French. Okay, so that will be this first statement here. Camilla will take chemistry is going to be P. Okay, notice we have an or in the middle. Okay, and then the second statement will be Q. Camilla will take French. So that will just be P V Q or P or Q. Okay, the next statement will be Camilla will not take chemistry. Notice we have a not there. Okay, and then or Camilla will not take French. So that will be squiggly P, negation of P. That is Camilla will not take chemistry. And or is going to be the V. And then Camilla will not take French will be the negation Q. So that's squiggly Q. Okay, when you have a compound statement that has more than one connective, in other words, we have maybe three or statements or more, we can use a comma to indicate which simple statements are to be grouped together. So a comma is like a grouping symbol, sort of like parentheses. Okay, so when you see a comma, that's grouping whatever's before the comma together and whatever's after the comma together. Okay, so the simple statements on the same side of the comma are to be grouped together within parentheses. So that's kind of what we can do is we can say kind of group each one in parentheses on either side of the comma. Okay, so here's an example. Let's say P represents dinner includes soup, Q represents dinner includes salad, and R would be dinner includes the vegetable of the day. Okay, so we're giving three different additional things for each statement. Okay, so let's write this following in symbolic form. Dinner includes soup and salad or vegetable of the day. Okay, so we see the comma right here, which means we're going to group in parentheses. I'll do it with the words, but you know, we can say now this symbol is going to, this and is going to go on the outside, but we can say and salad or vegetable of the day. Okay, so what we're kind of grouping together is what's after the comma, but be careful because this connector here stays with the first part. Okay, so we have kind of think of salad or vegetable of the day. So dinner includes salad or dinner includes vegetable of the day, and that's kind of the short way of saying this. Okay, and then dinner includes soup would be P and, so we're going to put the and on the outside of the parentheses. So you see, because we had the comma, I'll show you where the comma was, just on that logic, it was there, right? But we're going to group these two together, okay, Q or R, in other words, salad or vegetable today, and we'll put the and on the outside of the parentheses. So it's not exactly the same, but you can kind of see that that we have this thing being grouped because the comma is here, okay? So this is the way we would write it. You don't actually put the comma there. Okay, let's do the same three simple statements, and we want this one in symbolic form. Dinner includes soup and salad or vegetable today, okay? So you can see where the comma is, so we're going to kind of group this together. Dinner includes soup and salad. Now that would be P and Q in parentheses, and then we could say or, now we're going to say dinner includes the vegetable today. So we could see, because the comma is here, that we're going to group this stuff together. Dinner includes soup and salad, so that will be in parentheses, P and Q. Okay, let's look at another example. Let's say P is the house is for sale. Q is we can afford to buy the house. Now, notice these are both affirmative statements. There's no not in them. Okay. So let's say we have this statement, P and negation Q. Okay, so let's translate. So that means the house is for sale, and now negation Q, we cannot afford to buy the house. So we would say this, we can write in words as the house is for sale, and, because we have this connector, we cannot afford to buy the house because it's negation Q. Okay, here using the same simple statements, negation P or negation Q would say this: the house is not for sale, or we cannot afford to buy the house. Notice those are both negations. So that would be the house is not for sale, or we cannot afford to buy the house. And we're just translating statements here. We're not looking at what the truth values yet. Okay, here's where it gets a little more tricky. Now notice we have the negation outside the parentheses. So what we're going to do is we're going to say this part first, this P and Q, and then take the negation of that. So if we say this P and Q part first, here's what we get. We get the house is for sale, and we can afford to buy the house. Okay, so that would just be this inner part inside the parentheses. The house is for sale, and we can afford to buy the house. But because we have the negation outside, we can say this. We're going to add this at the beginning. It is not true that, or it is false that. Okay, so there's where the negation comes in. So our full statement would be, it is false that the house is for sale, and we cannot afford to buy the house. Now, notice that this it is false that negates everything that comes after that. So technically, there's a grouping symbol here, even though there's no comma. Okay. So when you see this thing like it is false that or it's not true that, everything after it gets grouped. Okay. So that's a little bit of a subtlety there. It is false that, and then this thing is totally negated. Okay. That P and Q. The house is for sale, and we can afford to buy the house. Okay. Let's talk about some if-then statements. Okay. The conditional is a symbol that's this arrow going to the right, okay? And that's right as if-then, okay? The part that comes before that is called the antecedent, okay? So it is a part of the statement, part before the arrow. Let's say part before the arrow, okay? And the consequent is the part that follows the arrow. So it's part after the arrow. So in this case, P is our antecedent, and our Q is our consequent, okay? And this literally means if P, then Q. That P arrow Q. And the arrow always points to the right. Okay, so let's look at an example. Let's say P represents the portrait as a pastel, and Q is the portrait is by Beth Anderson. So let's write a word statement using symbolic logic. So if this portrait is a pastel, then the portrait is by Beth Anderson. Okay, so that would be if-then. So if the portrait is a pastel is P, okay, then the portrait is by Beth Anderson, so P. So it would just be P or OQ would be our solution there. Okay. Notice there's a comma there. That's kind of usually that's kind of the way we write this if we have an if-then, that we say if this comma then. Okay. Sometimes we'll have this in a grouping. We'll have more than one statement here, and that would be grouped in parentheses with the comma there. Okay, using the same simple statements, let's look at this word statement and write it in symbolic logic. If the portrait is by Beth Anderson, then the portrait is not a pastel. So that would be Q, that would be the portrait is by Beth Anderson, arrow, negation P, because then the portrait is not a pastel. So we're going to have negation of P as the second statement, the consequent. So this is our, remember this is our antecedent, this is our consequent. Okay, and also using the same simple statements, write this one symbolically. It is false that if the portrait is by Beth Anderson, then the portrait is a pastel. So kind of the way we did before, we had the negation, we can say, okay, start with this. Take the if it is false that away for a minute and just look at if the portrait is by Beth Anderson, then the portrait is a pastel. Now that would give us that Q arrow P. Okay, so if Q then P, right? If the portrait is by Beth Anderson, then the portrait is a pastel. Okay. Now remember, it is false that negates everything after that. So we're negating this whole thing. So we're going to put the squiggly in front of the Q arrow P in parentheses. Okay, that's important that we have the parentheses here, because we're not just negating the Q, we're negating this whole if then. Okay, so it is false that negates that whole statement in blue. Okay, it doesn't have to have a comma there, notice, right? It is false that negates everything after that. Okay, so be careful with that. That's a little tricky. Okay, the biconditional is a double arrow. It's got an arrow pointing right and left, and we can say that that is as if and only if. Okay, and sometimes we write that as IFF. So when you see IFF, it means if and only if. So P double arrow Q is read P if and only if Q. Okay, so that's called our biconditional. So let's look at this example. Let's say P is Alex plays goalie on the lacrosse team. Q is the Huskies win the Champions Cup. Okay, and we want to write the symbolic statement in words. So we have P double arrow Q. So we can say P is Alex plays goalie on the lacrosse team. So Alex plays goalie on the lacrosse team if and only if, that's the double arrow, the Huskies win the Champions Cup. Okay, so that's how we would translate this into words. Alex plays goalie on the lacrosse team if and only if, that's where that double arrow comes in. Okay, so this is our P statement here. There's our double arrow underlined, and here's our Q statement. Okay. Let's translate this statement. Q if and only if negation P. Okay, so that would be the Huskies win the Champions Cup if and only if, double arrow, Alex does not play goalie on the lacrosse team. Okay, so we're just translating. We'll worry about what those actually mean when we do our truth tables and whatnot in later sections. Okay, now here we're going to translate a symbolic logic statement into words. So because we see the negation in front, let's focus on what's in the parentheses first. Okay, so we have P double arrow negation Q. So that would be this. Alex plays goalie on the lacrosse team if and only if the Huskies do not win the Champions Cup. Now let's do the negation. So we're going to put the it is false that in front. Okay, so worry about what's in the parentheses first and kind of translate that statement, and then put the it is false that in front because we're negating everything. Okay, so we can kind of do this after the fact, that it is false that as part of the words there. Okay, so just to summarize, negation is that squiggly in front of the statement. That's read as not, so not P. Okay. Conjunction is like an and. Okay, that's the upside down V for a little teepee or whatever. So that would be P and Q. Okay, that means both statements are happening or both are true. Disjunction is or. That would mean P or Q, and remember that's inclusive or, just like we did with sets. So that includes both conditions. Okay, or both P if both happen, right? Conditional would be if then P then Q. That's the arrow going to the right. Biconditional is if and only if, and that's the arrow going backwards and forwards, and we'll going both directions. So that would be P if and only if Q. We'll explain how, especially the biconditional and conditional, what those mean, because they do have different meanings, and I'll explain that in class a little bit more detail. Okay.